Hey everyone, welcome to Chapter 11, Section 5. Here I'm going to talk to you about areas of similar figures. So when we talked about similar figures in the past, we talked about them being proportional. And when we're talking about area, well, things are still going to be proportional, but this time around, everything's going to be squared. And everything's going to be squared because your unit for your areas are to the power of 2. Everything, if I do length times width, that's 2 dimensions. If I'm talking about proportionality of side lengths, that's 1 dimension because that's one side. So area is 2 sides, a length and a width. Whereas if you're talking about side lengths, that's just the length or the width. So that being said, I think it might help to just start doing some math. So you see that this green triangle has a side length of 15 and the blue triangle has a side length of 12. And if they're similar triangles, then if I do 15 over 12, I'll find the scale factor. The only thing is, that's the scale factor for the first dimension. That would only help me to figure out like the perimeter or another side. All that's in the first dimension. So if I take it and I square it to the second dimension, that's what the dimension of area is. That's why all your units are squared. So if I square that, well, 15 over 12, the fraction will simplify, and so basically it's going to get 25 over 16. So what I've identified here is my scale factor of my areas, okay? The next step would be to make a proportion. The areas, if the figures are similar, then the areas are similar. So I'm going to do a proportion. I'm going to go 25 over 16. I'm doing the left over the right triangle. And it says triangle JKL is 30 square inches. So this is 30. You don't know this one. So if I'm working left over right, I'm going to put X over 30. Okay, so just cross multiply and then divide, and you get X is going to be equal to 46.875 square inches. Alright? So that's it for the first example. So since I squared it to go forward to the area, what do you think I would do to find the similar volume? Well, you got to remember, volume is 3 dimensions. That's length times width times height. So if I have 3 dimensions, then I just need to cube my answer, power of 3. Okay, and then that's really all you would do to go from the first dimension, a side length, or your perimeter, to the volume. If I'm going to the second dimension, I square it. That's area. If I'm going to the third dimension volume, I cube it, or raise it to the power of 3. Now let's do a couple more examples on this. So here I have 8 and 4. So the first thing I'm going to do is figure out the scale factor of my areas. So 8 over 4, and I'm going to square it. When I square it, I just get 4. If you get a single number, throw it over 1. Okay? So that's my scale factor of areas. Okay? And then the next step would be to make a proportion. So I'm given the area of the blue one, 36. So I'm going to say 36 over, I don't know the other one, X equals, well, it should be the same proportion as 4 over 1. So cross multiply 36 times 1, which is 36, divided by 4, which is 9. So X equals 9 yards squared. That's the area of my smaller green square right there. Alright, now I'm going to repeat the process over here. I'm given 2 side lengths, so I'm going to go 5 over 7. I like to work from left to right. The most popular question I get is, how do you know what order to put it in? It doesn't really matter as long as you're consistent, but I like to work from left to right, and that way I never have to think about what order they're in. So I square it. 5 over 7 squared, that's going to get me 25 over 49. Okay, and that's my scale factor of my areas. Okay, so I typed it out that time, that way you don't have to read my handwriting. So now I'm going to do a proportion. The next step would be to make a proportion. So I can write 25 over 49 again if you want. Doesn't matter which one comes first. I know the last time I put it second. Equals 40 over, you don't know, 40 over x. Okay, so if you cross multiply and divide, cross multiply 49 and 40, divide by 25, you get x is equal to 78.4. And since this is an area now, meters squared. Okay? Let's move on to the back. So, to start off, I say the ratio of the area of figure A to figure B is 25 over 4. That's the ratio of areas. What is the ratio of the perimeters? Think about it. If I'm squaring it to go from perimeter to area, then I'm going to square root it to go backwards. Okay, so I'm going to go square root of 25 over 4, and that's going to give me 5 over 2. Alright, so the process, if you're going backwards, is to just square root it. Alright, so I'm going to repeat that process for these next few examples. So I'm given that triangle ABC area is 98 and triangle RTS is 50. So I have 98, I have 50 here. So I'm going to make the fraction, only this time instead of squaring it, I'm going to square root it, because I have to go backwards. Both of these are in inches squared. Well, I need to get that down to just say inches. So 98 over 50, square root of that, is going to simplify to 7 over 5. Alright? And that right there is my scale factor of just the sides. Okay? So if I have 7 over 5, well, what side am I given? 14 right there. So I can say 14 over x equals 7 over 5, and cross multiply and divide, and you get 10. X is 10 inches. My final answer does not have a squared with it, it's just the first power. So I got 2 more examples. I'm going to basically repeat the process. I'm given 2 areas, 875 over 315, square root that, okay, and that'll get me an answer of 5 over 3, and that's my scale factor. Alright, so now I can make a proportion with that, so I can say 5 over 3 equals, well, let's see here, I'm not given the left one, so we'll go x over 21. Cross multiply, divide, you're going to get x is equal to 35 centimeters. Okay, last one. I'm going to work from left to right. 153 over 272, square root that. Alright, that's going to get me 3 over 4. So that's my scale factor. So 3 over 4 equals 15 over x. Cross multiply, divide, you're going to get x is 20 inches. And that's it for the notes. Okay, so to recap, if you're going from a side to an area, you're going to do the ratio of your sides and square it, and then make a proportion. Alright, and then if you're going from the area to figure out the side, you're going to do the ratio of the sides, but square root it, and then make a proportion. And if at any time your scale factor turns out to be a whole number, or maybe it's just a decimal and it's not a fraction, just throw it over 1. All right? Thanks, everybody. Bye.